Hello, geospatial peeps. My name is Eli. I'm with Rogue Reconnaissance. I'm going to walk you through a project that we just got. It's through the Oregon Department of Forestry, and we're doing a demo to identify old downed woody debris. So we have two units, Steam Pot and Sabi Jabi. They're about 100 acres each. We actually did a demo a few months ago, and they were 30 to 40 acres, and there was quite a bit of pieces of wood on the ground. So now we're doing 100 and 130, and yeah, it's going to be a big project. Here we are, just to show for scale. There's our little trucks, and you can just see how much wood are in these units. Some areas not so bad, but others there's a ton. So they're basically trying to do post-harvest assessments to make sure there's enough wood left behind, as well as standing trees. Look at this. I mean, we're going to mark all this, we're going to capture it all, and we're going to calculate cubic feet. A little funny thing, after I stitched the images, we found out there's someone up here cutting logs right above us, and I had no idea he was up there. So here's Sabi Jabi, similar. This one has even more wood. And the goal of the project is we're going to document every piece of wood that is greater than 5 inches in diameter on the large end, and it has to be at least 3 feet long. So, for example, we'll zoom in. This piece, maybe it's really close, 6 inches. So really, that's the smallest diameter that we're going to try to pick up. A lot to sift through, but pretty obvious. And the first thing we're going to go through is we have these test areas. And this is how they're going to compare their data to ours. So we're going to kind of get into finding these test areas, drawing them, and we're going to just manually digitize the wood for these parts. And there I am, just to show for scale. It was near the coast, so you got to bring the surfboard just in case. If it was a rainy day, go surfing. All right, well, let's get into it. Here's step one. We brought in the orthomosaic. We processed the P1 data in Metashape. And as you can see, it's kind of in the middle of nowhere. For some reason, I'm sure people have answers for this. When I export with the correct EPSG or coordinate system out of Metashape, it still just kind of ends up in the middle of nowhere on ArcPro. The easiest way to fix it, it's just pretty common to find projection. And then just confirm, even though it already has the correct coordinate system, you just got to redo it, put it in, and if all goes well, it should disappear and go to the right area. There we have it, it's in the right area. So within this imagery, this is again the P1, really high megapixels, and we're identifying all the down woody debris. And as you can see, it's really high resolution. We could get in there. We can actually see what class these pieces of wood are. So as we previously talked, class 1 through 2, recently down, usually has a nice cut end. It's squared off. It's a solid piece of wood. If you go in closer, you can see this piece pretty much broken up, disintegrated. We have another one right here. This is going to be class 3 through 5. So majority is going to be solid pieces, and the way we're marking them again is if it's fully disintegrated, falling apart, really obvious, it's going to be a 3 through 5. So This one's almost on the border. It could be a 1 through 2, but yeah, I think I'll go through 3 through 5 for these two. Now what we need to do is so ODF has test areas, and the point of these areas are to basically make sure the drone data is actually accurate. The whole point of this demo is we want to see, can we count down woody debris with a drone instead of having humans having to go through the whole unit. Before they would do small little sections to do these kind of surveys, and as you can see, it varies greatly throughout the whole unit how much wood there is. So if we actually can get a decent accurate count for the whole unit, that would be excellent. This unit's relatively flat, but like the other one, Steam Pot, which we'll kind of go into later, really steep. I just walked to some of the test units and out of breath, kind of falling everywhere. It's really uneven terrain. So we're going to just draw basically polygons of these areas, and we're going to end up cutting it and doing calculations and comparing it to the data on the ground. So we got our test areas. That one was a little bit harder because of the tree canopy, but now we're going to kind of go into how we're going to mark the trees, and we're going to mark them first and then go through after and actually do the classifications. So the 1 through 2 and 3 through 5. So let's dive in. So the fun begins. So the parameters of this project, I'm pretty sure it's anything over 6 inches in diameter on the big end, and it has to be at least 3 feet long. If it's smaller than 3 feet or 6 inches in diameter on the big end, it doesn't count. Generally, we just still mark everything that we see, and once we calculate everything, we will kind of take those results out. So anything you see, mark it. If it's smaller, we'll just delete it later or disqualify it. And I'm doing all the way outside of the test area, and we'll clip it later. That way I don't have to go back and redo it. Right here, really obvious, class 3 through 5. So it's basically sunken into the ground, totally decomposing, falling apart. There's another one right here that he marked. Um, Realistically, if he didn't mark it, I don't know if I would see it. So I'm not going to mark it and be a little bit more realistic. This one, obvious. And if it's all chopped up right there, I just cut it off. And the people on the ground kind of agreed. They'll usually cut it off at that point as well. It looks like he counted that one, but it's right on the line for me. So won't count it. Again, chopped off. So take it right there. That's a good example. If you see a log that's kind of hard to see through others on top of it, you can zoom out and usually you can see it through the brush, or maybe there's some dirt piled on it or something. Just zoom out, you get a better look. So that was a full circle around the unit, not hard. Um, if you're doing it by hand on the ground, you definitely wouldn't be able to go that quickly. So we still need to do this area, and we'll kind of do a quick double check to make sure we didn't miss anything. Okay, so that's complete for digitizing. Now we're just going to go through all the layers and decide whether or not it's class 3 through 5. Luckily, this one's pretty straightforward. So now we have this code in the notebook that we're kind of building for this project. So it's adding fields, attributes, everything that's kind of relevant to the data. We even have an equation. It's going to calculate the cubic feet for each piece. We're going to add a small and large width of the piece of wood. So what it does is it takes the longest edge, and that's the length, and then it takes the shortest edge, which is the width small, and the second shortest edge, which is the width big. And with those three things, we can calculate the cubic feet with that equation. We'll have attributes for what unit it is, things like that. It's looking good. Let's see if it got us those attributes. So yeah, now we're good. We have the unit in there. We'll populate these fields. Probably we'll update the code so it'll do it on its own. And you can see all these blank values. Whatever I did not classify as a 3, which is fully decomposed, it's going to be a 1 through 2. So that's something else we'll update shortly. All the attributes are now cleaned up, and we have everything. So if it's a value of 1, it's decomposition of 1 through 2. We have our length and feet, width small in inches, width big. So we're just going to kind of confirm some of these really quick, make sure nothing went wrong. Sometimes if you click too fast, you might not have a rectangle, and so it won't calculate correctly. So we'll just check a few. So length, just about 16 feet, that's right. And width on the small end, or the big end over here first, that should be just under a foot. So that's correct. Small end, 8 inches, 0.7. Yeah, I trust that. Check out another one randomly. So length, just over 3 feet. Looks good. Width small, 8 inches, so under a foot. Yep. And big, 11, should be just under a foot. We'll check one more just to be safe. So that's a really large one, 23 feet. Looks good. Small end, 3 inches. Great. 7 inches, just over 7. So should be just over half a foot. Great. So that looks good. The cubic feet, sometimes you'll see a huge number in there. We just want to confirm like 186. That's a really large piece. Class 3, so probably a really large, rotten, falling apart log. Let's confirm it. And yep, falling apart, really wide, long. That makes sense. So we'll check one more. 95 cubic feet, so pretty big. Again, well, not class 3, value of 3, probably class 4 or 5. And again, large, falling apart, that makes sense. So we'll classify them, kind of make it a little easier to see. And we'll match their color scheme, so they're doing blue for 3 through 5 and orange for 1 through 2. And we'll just stick with an outline, no fill. So there we go, one test area is done, 2 more to go. And they got a big meeting tomorrow, so they kind of want to have these numbers and talk about it, see how close it was. We did do a Steampot, and turn this back on. And the 3 through 5s was pretty far off, which is expected. It's pretty hard to see them, they're buried. But all the 1 through 2s, which really matters for reporting, we were within 5% accuracy, which is a lot better than we thought. We're kind of going for 20, and so we did way better than we thought we would. 5%, that's amazing. If we can do that universally, I don't see a problem why any of this would ever fail for accuracies, but it probably won't be that way. These are pretty clean units, it's easy to see, and the pieces of wood are marked, so that's a really good guiding factor for us. But regardless, the fact that we're measuring from the air and we're within 5% of a human on the ground, that's amazing. So we'll see if this next unit, we're going to do 2 more units, and we'll go through it together just to kind of see the process. Test areas are done. So we have A, B, and C. Actually, it's A, B, and C that way. And I don't know the numbers yet that the Department of Forestry has, so I'm going to send these in. And they're going to compare the numbers and have a meeting about it tomorrow to see how to improve it, maybe better techniques, more plots, things like that. So it all looks good. All the numbers seem normal to me. For their meeting tomorrow, we're just going to do 5 maps, made them really quick, just to kind of quickly present them, a little pie chart so they can see the numbers and compare them. And another metric is to see how many pieces, and for the class 1 and 2, how many of those were over 20 inches. So we'll see how the meeting goes tomorrow and whether or not we'll do this 15 to 20 times a year. We'll find out, and I believe, yeah, it's going to be a good tool for people to use in the future. Save a lot of time for the employees having to go out there and manually do this. I don't think it will completely replace it, but I still think it's a great option to cover a ton of units in a small amount of time.